We already know these three equations of kinematics, that is V is equal to U plus AT, S is equal to UT plus half AT square, and V square is equal to U square plus 2AS. And based upon these three equations, we have done numerous calculations in our previous video session. And those calculations or those problems were very easy because you only had to substitute the values. Now in upcoming sessions and this session, we will do some problems which will involve some thinking, and that will be very important to understand the concepts thoroughly. So let's do the first problem. A car driver moving with a velocity 60 meter per second finds a cat at a distance 100 meter. He instantly applies the brake. What is the time taken if he stops within the 2 meter of the cat? Now before solving the problem, let's visualize using the diagram. So the simple diagram I can draw is like this. This is the road, and let's say this is the car. It's here, and the car is moving, suppose, in the right direction. Now the instance I draw this arrow, I will assume that it is moving in right direction is the positive direction, and the left direction is negative direction. Now see, the car driver is applying the brake. That means this car is going to stop, and to stop it we had to reduce its velocity uh, continuously, and at certain instance it will be zero. So this motion is a deaccelerated motion or a retardation motion which involves retardation. So now the acceleration must be in the opposite direction of the movement of the car driver, that is in the negative direction. So people often confuse with deceleration, that it is always negative. No, it is not, because if I am moving in the negative direction, that is the left direction, and if I have some negative acceleration, let's say minus 2 meter per second square, even then this is accelerated motion, not decelerated motion, because the acceleration is in the direction of motion. So I can safely say that if the acceleration is in the opposite direction of the motion, then it is retardation or deacceleration. Now let's do this problem. Now he finds a cat at, let's say, 100 meter distance from here. Let's say the cat is here, 100 meter. He applies the brake at that instance. So what is the time taken if he stops within 2 meter of the cat? So within 2 meter means this x coordinate is 98 meter. So in 98 meter he has to stop his car. So now we know V is equal to 0, that is the final velocity. U is equal to 60 meter per second, and that is positive because it is in the right direction. And what is S? S is 98 minus 0, that is xf minus xi, the final position minus initial position. So this is 98 meter. So now let's apply this. V square is equal to U square minus 2AS, because A is in the negative direction or left direction. Now V square is 0, and this is 60 square minus 2A into 98. This is 2 into 98 A. I have taken it on the left side, and this is 60 into 60. So this becomes A is equal to 60 into 60 divided by 2 into 98 meter per second square. So this becomes, this will be 30. If I divide it by 2, I will again divide this by 2. So this is 49, and this is 30 again. So this is 900 divided by 49 meter per second square. This is the answer. Let's do the next problem. A bullet fired with the velocity 200 meter per second on a metal plate rebounds with the velocity 100 meter per second. Find its acceleration during the contact with the metal plate. Assume the time of contact to be 0.002 seconds. Now, this question will really test our understanding of the directions in the kinematics. So let's do this. So let's say the bullet is fired in the right direction. This velocity is 200 meter per second, and now let's take right direction as the positive and the left direction as a negative. Now after rebounding, it is rebounding, and after 0.002 seconds it rebounds with the velocity 100 meter per second. Now what will be the acceleration? Now acceleration is change in velocity, and the change taken in certain interval, that is suppose delta t it is, then we will divide it by delta t. So this will be, this velocity will be minus, so this is minus 100 because it is in the left direction, and the initial is positive, so this is 100 minus 200 divided by the time interval, which is 0.002 seconds. So this is meter per second, and this becomes minus 300 divided by, now let's take to the point over here, so it will be 2 into 10 to the power minus 3 meter per second square. So this is 150 into 10 to the power 3 meter per second square with a minus sign. So I can also write this as minus 1.5 into 10 to the power 5 meter per second square. So this is the acceleration, and this acceleration is in the left direction as indicated by this negative sign. The displacement of the particle is given as x equal to 4t square. So this t is a time, and calculate the acceleration at time t equal to 2 seconds. So now x is given to be 4t square. Now to know about its velocity, I can divide it, I can take a differentiation with respect to t. So it will be dx by dt, which is equal to velocity, this is equal to 8t, 8 times t. Now if I again divide it, take a derivative of this, then I will get acceleration. So what is then acceleration? It is 8. So 8 meter per second square is the acceleration, and it is constant, and hence even at t equal to 2 seconds the acceleration will be 8 meter per second square. Had it been something like this, 8t meter per second square, then it would have been 16 meter per second square, like that. But now it is constant, and hence it will be the same at t equal to 2 seconds.